All right, I'm recording the class lecture so I'll put it up there later. All right, so multiplying. When you multiply, this is the method I prefer, is the distribution method. Basically what we do is we have one polynomial times another, and to get the product, you multiply every term by every term. So she wrote this out in gory detail, and I'm going to show you. I'm going to do it over here just to. So what she did was she does the first term times the first, the second, the third. So she does 3g times 2g squared. So if I multiply those, I just do that in my head. I get 6g cubed. See that? I add the exponents, right? And multiply 3 times 2. Then I do 3g times 4g. So that would be 12. G times g is g squared. And then I do 3g times -4, so it'd be -4g. Okay. So I've multiplied the first term there by every term in the second expression. Now I'm going to multiply the second term by every term. So I start with -3. Make sure you keep the sign. -3 times 2g squared. I'm going to put this down here. Is -6g squared. -3 times 4g is -12g. And -3 times -4 is -12. You see, I've multiplied every term by every term, and that's my product. Now I just add up like terms. All right. So I get 6g cubed. 12 minus 6 would be +6. G squared. I don't do anything with the exponents, just add like terms. -4, -12 is -16g, and then I have -12. So that would be my product. Okay. Any questions on that? We good? All right. So just to kind of mention this, some people, I don't know if there's anybody here that does it. There is another method called the box method. What you do is make a box. This would be a 2x3 box because there's 2 terms in the first guy and 3 terms in the second guy. You put the terms on the outside. And basically you multiply every row by every column. So this would be like 6g cubed. Multiply this times this. 2 times -3 is -6g squared. 4g times 3g is 12g squared. 4g times -3 is -12g. -3 times negative, that's going to be -12g again, right? Yes. And then that's going to be +12. Did I do something wrong? Seems to me like I'm not getting the same answer. What did I do wrong? Oh, I did something wrong. Did I do something wrong? -4, it's going to be +12. I'm getting a different answer, so I'm going to go back and check myself here. 12 minus 6 is 6, and I got negative. So this should, I'm getting a -4 here. Which one was right? So it seems like it's here I messed up on. The third one is 3g. It's -12. 3g times negative. How am I getting -4g? Oh, that's why. See my multiplication error here? So 3g times 4 is -12g. Oops. Let me fix that. This should be a -24g. Okay, so I messed up. All right, so, and again, you can see this pretty much works out to the same thing once I fix my error. These two add together to get 12 minus 6 is 6q squared. -12 and -12 is -24g. You have your +12. So it does this minus +12. Jeez. Negative, this is plus, that's a +12, right? Because -3 times -4 is +12. Okay. Wow. All right. You okay with that? Now that I fixed my algebra? All right. Even I can make algebra mistakes. All right, so we're going to multiply, basically when you have a monomial, you just distribute it through. This is a monomial one term. So 2x times x would be 2x squared. Is that right? And then you carry the plus. 2x times 3 would be 6x, right? And I multiplied. You guys okay with this? You're quiet today. Yeah, okay. So the one thing you have to keep in mind, here I'm gonna multiply, I'm gonna distribute. What's 2x squared times x cubed?
Do you just add the exponents on that when you multiply them, or do you need to multiply the exponents?
Okay, so when, remember, this exponent rules always hold, right? So I'm multiplying, so what do I do with the exponents?
Multiply?
Okay, so let's go back to the exponent
Add
rules.
You have to add them.
Yeah, you add them.
Just think about x to the a times x to the b, right? Is x to the a plus b, that's always true, right? Even when I'm doing stuff like this. You multiply when you have a power to a power, right? But I don't have that here. I have 2x's, so I'm going to add the exponents. So it's going to be 2x to the 5th. Is that right? And what's 2x squared times 3x then?
6x cubed.
All right, so that's it. That's your product. Okay, so the exponent rules still hold because you're multiplying, you add the exponents. All right, is that all right? Any questions? All right, this next one, I guess we'll do the distribution method. I'll use blue. So I'm going to multiply negative 3x by all these guys, right? So negative 3x times x squared is negative 3x cubed. And negative 3x times x is negative 3x squared. And then negative 3x times negative 3 is positive 9x. Hopefully I did all the multiplying right this time. All right, so I'd multiply the first term by all the terms in the second guy. Now I'm going to take the second term. I'm going to multiply him by all these guys. Okay. And I'll line them up underneath each other just because it's easier to add them then. So negative 4 times x squared is negative 4x squared. So I just line it up under the x squareds. Negative 4 times x, negative 4x, and negative 4 times negative 3 is plus 12, right? So you see that I just multiplied every term by every term. And now I add them up. So I get negative 3x cubed. I have a negative 3 and a negative 4, so that's negative 7. And 9 minus 4 would be 5x. All right, now we're multiplied out. Okay. And we're going to talk about FOIL here. I think what I'm going to do for D, just because we're going to talk about FOIL, I'm going to show you the box just to show you the box. Okay. So if you like the box method, what you do, this is going to be, you have 2 terms by 2 terms. So it's a 2 by 2 box. Do x plus y and x minus y. They just multiply. All right. So x times x is x squared, x times y is xy, x times negative y is negative xy, and negative y times y is negative y squared. So when I add these guys together, you see these guys, that's positive and that's negative, so when you add them together, they cancel each other out. So you end up getting x squared minus y squared, all right? Which is going to become important to us because there's something about going from here to there that would be the factored form of that. All right, this is what we call a difference of squares. There are 2 squares, 2 numbers that are squared and we're subtracting them. Let's call it difference of squares. And I don't care how you multiply as long as you can multiply. All right, any questions? Good. All right, so let's talk about multiplying a binomial by a binomial. A binomial means 2 terms by 2 terms. All right, you're still multiplying every term by every term. They nickname this FOIL because when you do this, FOIL stands for you multiply the firsts, outsides, inside terms, and lasts. Okay, so what she means by the first would be the first 2 terms here. So 2x times 5x would be 10x squared. That's your first. Your outsides are the two on the outside. So it's 5x times 7 would be 35x. Your insides would be the two in the middle. So -3 times 2x is -6x. And your last would be -3 and 7 would be -21. All right, so FOIL stands for first, outside, inside, last. All right, now we're not done, I should say there, because we have to combine like terms. The outsides and the insides combine because they're the same. So 35 minus 6 is 29, right? So we make it 29x. All right, is that right? You guys remember FOIL? High school? Yeah. All right, so we're gonna practice doing a couple by FOIL just to make sure we're in good shape here. So we're going to do first, so x times x is x squared. Outsides would be these two guys on the outside, so that's plus 5x. Insides, -2x. And lasts, -10. All right, so once I'm done all that, I combine the outsides and the insides here. 5x minus 2x is 3x. And I'm done. Okay, I've multiplied it out. All right, let's do the next one. So we're going to do first. So 2x times 3x is 6x squared. Outsides, 3x times -7, -21x. Insides, 4 times 2 is 8x. And last would be -28. All right. Then you combine the outsides and the insides. Let's see, -21 and 8 is 13. No, -13. Is that right? Yeah. Any questions? You guys okay with this? Yeah. Okay. All right, so I'll tell you what, you guys do C on your own, and we'll see if we agree. All right, take a second and do C, and I'm going to do it in my head. Well, maybe my head. All right, anybody get the answer yet? Still working it?
I think I got the answer.
Yeah.
I got 12x squared minus 47x plus 40.
Got it right. Okay, good deal. All right, do I need to go over that one? Are you guys good?
Yes, ma'am, we're good.
Okay, all right, so let's do the last one. Last one, again, you multiply the first, you get 9x squared. Outsides, minus 21x. Insides, 21x. And last would be -7 times 7 is -49. So the outsides and the insides are the same, so they go away. And I get 9x squared minus 49. That's important. This is called the difference of squares again, because you see that these two are the same except one's plus and one's minus. When that happens, the outsides and the insides always cancel. I'll just write the term here since we're going to talk about the difference. squares. All right. So this is going to be the end of my stuff for today. Like I said, there's a video on 2.1 that talks about factoring. And that's what I really want to talk to you a little bit about that, but we'll get there. All right, so there's a video on 2.1. And so we're going to go back up and we're going to cover 1.2 in the other part of the packet. That's the 1324 stuff. All right, let me find it. Nope. Let's see, we did matrices the other day. Okay, we'll cover 1.2. All right, so we're going to talk about lines. Part of what you guys are doing or will be doing. Have you done, what is it, profit and revenue costs? Have you done that stuff yet? Not yet, right? Not yet. So you're gonna need to work with their linear. All right, so you have to work with lines. All right, so we're going to talk about lines. All right, so we'll do a little review. This is really stuff that could be for my class, but it's for his class, but it's kind of like, you know, it's algebra 2, right? So, all right, so we're going to talk about some things we need to know about lines. First of all, linear equations, lines, are used throughout algebra in many courses, including 1324 and 1325. There are 3 different ways to write lines. You guys remember y equals mx plus b. M is called the slope. And b is called the y-intercept. It's where it crosses the y-axis. If I have a line here, this number right here is b, and m is a measure of how steep that line is. All right. The standard form is ax plus by equals c. It's not a very interesting form because it doesn't give us a lot of information, but it's there. And the point slope form, I personally really like. It's very useful in calculus to find the tangent line. This where basically m is the slope and x1, y1 is any point on the line. So if I have a point, the slope that I have handy, I can use point slope form. All right. X is the independent variable. Y is the dependent variable. All right. Y changes as we vary x. All right. Okay, so slope is m. It's a change in y over the change in x. That term delta means change in. It's a measure of how fast y is changing as x changes. So it's delta y over delta x. So if I have 2 points, if I know 2 points on the line, x1, y1, the slope is y2 minus y1 over x2 minus x1. It's a change in y over change in x. All right, and another way to call slope, you heard it called rise over run. All right, that's slope. It's how much you go up over how much you go over. A few things about slope, I guess I should say. A positive slope is rising to the right. This is a positive slope. Negative slope is falling. As x goes up, y goes down. And then some slopes, this is a 0 slope, is a flat line. And a vertical line has infinite or undefined slope. It's infinitely steep. Okay. All right, so the equation of a line, the way you can tell a line, I forgot to mention, you'll notice these only have one y and one x. They don't have any powers of x, they don't have any powers of y. They're lines, you just have an x and a y. All right, so some things they might ask you to do. They're going to ask you is 3, 2 as solution to this. Well, if it's a solution, I should be able to plug it in and it should work, right? So this 3 is x and 2 is y. So I pretty much just plug it in. So I do 3 times 3 minus 5 times 2. My question is, does that equal 1? If it does equal 1, it's a solution. If it doesn't equal 1, it's not. So 3 times 3 is 9, minus 5 times 2 is 10. Well, that's -1, right? So that does not equal 1, right? So if it had equaled 1, it would be on the line, but because it doesn't, it's not. Okay. So one way to tell if they're on the line is plug the point in and see if it works. Is that right? All right, and now this part B is asking the same question, just in a different way. It says it's -2, 4 on the graph. So if it's on the graph of the line, that means if I plug in x and y, it should work in the equation. So this is x and this is y. I'm gonna plug them in. So y is 4 and x is -2. I get 4 equals -4 minus 8. Well, guess what? 4 does not equal -12, so no way that's not on the line, right? Okay, for it to be on the line, it would have to work. All right, so you can get slopes of graphs and y-intercepts from graphs. Just be careful that you always read the scale of the graph. Sometimes they change the scales. They were very nice to you. I don't think they did here, but just something I should warn you about. So what you want to do, if you want to find the slope of the line, you pick 2 nice points. They gave them to you here that were on the line. That a nice point happens at where the guys cross the grids where they cross. So if I look at this point, I can do points, but I can also just count. I can make myself a little triangle. I go, okay, I went up 1, 2, 3. I went up 3 and over 1, 2, 3, 4, 5. I went up 3 and over 5. So since the slope is rise over run, the rise is 3 and the run is 5. So the slope of that line is 3/5. That's all I need to do. Okay. What's the y-intercept? What's the y-intercept? I didn't ask it, but I'm asking it.
-2.
Okay, that's what I was hoping somebody would say, because that's not right. You know what that is?
It's
That's
+2.
Oh, I'm sorry, I meant positive. Is it +1? I'm sorry.
Yeah, okay, I'm glad you did that, because the -2 is the x-intercept, right? It's where it crosses the x-axis. The y-intercept is 1, is where it crosses the y-axis. This is your y-intercept right here. Okay, so I want to make you aware of that.
Oh, my bad. I was looking at the second one.
Oh, you're looking at the second one.
I don't know. My bad.
All right, never mind. Okay, I'll let you answer the second one though. All right. Let's find the slope, right? So the slope, I'm going to make me a triangle. It doesn't matter which way you make it. You can make it underneath it or you can make it above it. It doesn't matter. I'm going, let's see, the rise is 4.
4,
The run is
6.
6, right? So the slope would be rise over run. So that would be 4/6. You can reduce that, right? Make it 2/3. All right, what's my y-intercept? Just because I want you to make sure you got it.
4.
Right, it's where it crosses that y-axis, right? This is your B, okay? All right. Now, this next one, they don't give me points, so I gotta find 2 nice points. There's lots of nice points. Let's see, I like this point, and I like this point, okay? So, again, rise over run. Now be careful with this. I'm going down 2 here. So my rise is -2, and my run is 1, right? I went over 1. All right, see that slope is negative because it's going down. So n would be -2 over 1. So it's -2. All right, Is that okay? And the B is 2, right? I think we got that now. All right, this next one, we got to pick some nice points. Here's a nice point. Where's another nice point? It doesn't matter if you pick 2 consecutively, because what's going to happen is even if you don't pick 2 consecutive ones, you can reduce the fraction anyways, as long as you get 2 nice points. So let's see, for this particular picture, it looks like my, that's down 2 is my rise, my run is over 1, 2, 3, 4, 5, 6. My run is positive 6, right? So slope is rise over run. So it's negative 2 over 6. If I reduce it, it's negative 1/3. Okay? So remember, if it's going down, the slope needs to be negative. If it's going up, it's positive. All right? We good? Okay, so she wants you to build a second point. The reason is that way we can use the calculator to get the equation of the line. If I have 2 points, I can get the equation of the line using the calculator. So you're like, why would I do this? Because this is going to allow us to use our calculator. All right, so it says every line except for the vertical line is different, but you can't use your calculator on that. All right, so suppose you have the ordered pair 3, 2, and you know the slope is 3/5. All right, I can get another point on this graph. Because if I know that 3/5 is rise over run, what I'm going to do is I'm going to plot the point 3, 2. So 3, 2 is like right here. That's where she plotted it. I'm going to go up 3 and over 5. That's my rise over run. So I go up 3 and over 5. And I can read this next point. This next point is going to be, if I look at the graph, it's 8, 5, right? So what I have now are 2 points of that line. Okay. And why would I want to do that? Well, let me show you a couple things. Okay, I'm gonna expand on this a little bit. First of all, there was point slope form. If you're a point slope form fan, all right, I don't need any more information. I have a point. I have a point is 3, 2, and I have a slope is 3/5. And I can just plug that into that equation that they gave me. So this is x1 and y1. So I do y minus 2, the m is 3/5 times x minus 3. This is the equation of the line. I might have to do a little bit of math here, but this is ultimately the equation of that line. I'm gonna solve for it because I'm gonna show you something with the calculator. I'm gonna distribute the 3/5. 3/5 times 3, you can do it on a calculator. You're gonna get 9/5. And then I have to add 2 over. Put it in mx plus b form. Let's see, that's going to be 10/5 minus 9/5. It's going to end up being 1/5 here. Now, that's the equation of the line by hand. But if you know 2 points, this is why she wants you to find 2 points. You can also just plug them into the calculator and let the calculator do the work for you. So I want to show you how to do that in your calculator. All right, so I'm going to pull up the Smart View. Let's see, where are you? All right. So there's my calculator. What I'm going to do is if I plug the 2 points that I had, which was 3, 2, and 8, 5, into the calculator, it can find the equation of the line. So the way that you do that is in your calculator, you press the stat button, S-T-A-T for statistics, and you press edit, which is number 1. So you just press enter. So you press stat and then enter. And I'm going to put in L1 and L2 each of these points. So I'm going to put like 3, 2 like this, 3, enter. I'm going to put the y's in L2. So I put the x's in L1, the y's in L2. And the other point was 8, 5. So I put 8, 5. Okay. I need 2 points. That's all I need to determine the equation of line. So once I have them in my lists, I'm going to quit out of these lists. I hit second quit. Then I go back to stat. This is where all my statistics stuff is. Stat. And I'm going over to CALC. I'm going to go over to calculate. All right. And you'll see there's something that says lin reg number 4. That's going to give you the equation of the line. So you're going to press number 4 and see where it says X is in L1, Y is in L2. That's what I want, right? And I'm going to calculate it. I'm going to go down here. I'm just going to press enter. So I get 0.6x plus 0.2, 0.6x plus 0.2, which is the same as the equation I just got. So just to convince you, 0.6x plus 0.2. So what if I did this? 0.6, if I convert it to a fraction, it's 3/5. That was a slope, right? And 0.2. All right, and that was the plus the 1/5. All right, so I got 3/5 x plus 1/5, and that's what I got. All right, so you can always use your calculator. If you know 2 points of the line, you can use your calculator to find that equation of the line. All right, so that's where she's going with this. All right, so let's work an example. Find another point on the line with a given point that has a reference slope. Plot on the graph and also determine its coordinates. So from the point, I'm at the point 3, 4. I have the slope is 2/3. So remember 2/3. This is rise over run. So from this point, I'm going to go up 2 and over 3. 1, 2, 3. Put a dot right there. Okay, up 2 over 3. So the new point, I can just read it right off the graph, is 6, 6. The original point was 3, 4. Okay, so that's all we're doing. If I wanted the equation now, I can go plug it in the calculator. All right. So what if the point doesn't fit on the graph? All right, let's take a look at this example. The slope is -4/5. The negative means I'm going down 4, right? So if I go down 4, that's fine. But then if I try to go over 5, I run out of graph, right? And I go, oh, wait, what do? I can go the other way. All right, I can also write this as 4 over -5, which tells me I can go up 5, up 4. That's the rise. I'm going -5 to the left. So there's my new point right there. All right, and you can verify it. Just do the slope this way. Go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. And oh yeah, I'm where I need to be. So I know that point's work. So the 0.06 would work, and the point there is 5, 2. Okay. All right, we good? Okay. Now, what happens if they get nasty? You really don't need to graph them, okay? If you think about it, I'm going to find another point, given that I know what the point is. All right, so I have this nasty point, but I know the slope is -4/15, right? So I'm going to think of -4/15. I'm going to write it this way. This is rise over run, right? So think of it, y is going to go down 4 and x is going to go up 15. So if I take the point 350, 20, and the change in y, they're going to go -4 for y, and for the change in x, you're going to go 15 up. So I'm going to add 15. You see, I can just add it, and that gives me a new point. So I got 350 plus 15 is 365, and 20 minus 4 is 16. So that is another point on that line. So I really don't need a graph for it at all. Okay. All right, and then I can get the equation in my calculator. All right, so if I think of this guy, 2/35, again, this is the change in y over the change in x. So here's my point, here's x, here's y. Y is going up 2 and x is going up 35. And I end up with 65 and 6402. So I can use the slope to get another point always. Then I can plug them in my calculator. Okay. All right. So the last thing we need to do, wow, this really went fast today. All right. from the point 30, 60, 400, using a slope of 40, find another ordered pair. All right, so what I want you to think is like 40, okay, there's no bottom, but 40 is the same as 40 over 1. Right, so if you don't have anything underneath, just put a 1 underneath. And this is the change in y over the change in x. All right, so I take the point, and the change in y is 40. So if I add 40 to that, I get 6440. Should put that there. I'm going to add 1 to x. Right, and here's my new point. All right, just to go back over again, since I have a little bit of time, I'm going to put those points in the calculator and find the equation line just so you can see that one more time. All right. So once I got my 2 points, I'm going to go into stat. Let me mention a few things to you about, you can clear the points out of the lists. He used the clear button, all right? Just to mention to you, if you go up here, if you go up to the top and hit clear, it'll clear the list. Do not hit delete. If you hit delete, should I do it? I don't want to do it. If I hit delete, the list is going to go away. And then you have to reset the memory of the calculator to get it back. So don't hit delete, hit clear, all right? But if you have, if you're missing
Tell me
a list,
why.
huh?
Oh, never mind.
What's the question?
Oh, how do we clear the calculator, like you said, because I kind of already deleted the list.
Okay, would you ask that question again?
I already deleted the list, so like, how do we get it back again?
Did you hear what he said?
He lost the list. So he did
my
exactly
bad,
what
my
you
bad.
You lost the list.
Yeah,
Okay, let's
yeah.
lose the list. All right, this is how you lose a list. You go up here, you don't hit clear, you hit delete. Oh, it's gone. My L1's gone, right? You see? So the only way to get it back is to reset the calculator. The way that you do that is you hit second memory. We want to go to 7, reset. Second memory 7. We're going to go, actually, I want to go to defaults, I think. Or do I do all? I think all memory. I think that'll work. All memory. So I'm going to do that and reset. And let's go back and check stat. Let's make sure it's there. If I press edit, voila, it came back. Okay.
Okay, all right,
You have
thank
to
you.
reset the calculator. So I've done it before. So if you delete a list by accident, reset the memory on the calculator. Okay.
So do you
Alright.
also have to re-download whatever you've downloaded prior? Like say we had to download something onto our calculator for whatever type of reason and we accidentally deleted or had to, go through and delete all the memory. Do we have to go ahead and re-download those onto the calculator?
Okay. So what the heck? While I have time. All right. If you've downloaded a program, it'll clear the program out of memory unless you archive it. Let's see if I remember how to archive. Yeah, if you hit, like, I don't have a program in there right now, but if I were to hit second memory, you see this thing that says archive?
Uh-huh.
If you say archive, and if I had a program, I would go up to program and type that program name there. I don't have it. I press enter, and there's going to be a little star that chops up on the calculator next to it, which means it's archived.
Mm-hmm.
What that means, when you clear the memory, it will not go away.
Okay, cool.
Okay, but for you to use it again, you have to go back to memory and unarchive it. Okay. So
Okay.
any programs that are archived can't be used until you unarchive them. So you second memory. You see the thing number 6 that says unarchive?
Uh-huh.
I would do that so I can use the program. Okay. But if you archive a program, it will not clear out of your memory. You clear the calculator. Okay.
Okay. Thank you so much.
All right, so let's just go back and let's put these points in just for the experience of it. So I'm going to press stat, edit. All right, so I'm going to put 30, 6400 in there. Sorry, 6400. And the other point was 31, 64, 40. And then I'm going to quit. So I hit second quit. Then I go to stat, go over to calculate, and I want lin rate, number 4. And go down to calculate. Since I got a little bit extra time, if you want to store the equation, you see this thing that says store? If you like, you can store it in Y1, like if you want to graph it. So if I go to bears, And if I go over to y-varies and say function, and then I want y1, it'll store the equation in y1 for you if you want it stored there. All right, so there it is. It's 40x plus 5200. If you go to y equals, you see because I stored it, it's there in my grapher. Okay, so there's some calculator ease for you guys. Okay, okay, I'm totally done. Okay, wow, that went really, really fast this week. All right, so a couple things. So remember that I did 1, 2 today. I'm going to do 2, 2 on Thursday. We're going to start factoring, and I really kind of want to hit that hard. 4, 1, I want to talk. I'll talk more about that on Thursday. Yeah, okay. But these videos, 2, 1 and 4, 1 are already up there for you. Your homework's up, ready to go. Your quiz is up, ready to go. There is a discussion post under 4, 1. I think I put it up there. If I haven't, I will very shortly. Okay. So we're done. All right. You have any questions about anything? Everything going okay?
When did you say the quiz was due? I'm sorry.
They're always due Sundays at midnight.
Okay.
Okay.
So after we get through with everything, just go ahead and hit it. Right.
Yeah, you got to get through this week, right, before you take the quiz. Yeah.
Yeah, right.
Yeah. Okay. So over this stuff.
All right, thank you.
Oh, I actually had a strange question.
Yeah.
She told us that we needed some online stimulus download. Is that to our calculator? Is
Oh, what?
an online stimulus, something about online stimulus for unit 3?
Simplex?
Yeah, simplex. There we go.
Oh, okay. Yes.
Stimulus. I'm thinking of COVID over here.
What did she do? Did she give you the code for it and you have to type it in? How are we going to do that?
I have no idea. That's what I was asking. Is that something for our calculator? Or is that something?
I can't show you my calculator, but yeah, my calculator is a program called Simplex on it. If you come to class, I can give you the program, but how is she going to get you guys the program if you're not coming to class? Did she say?
She said there was something about an online, like a way we could do it online, but I'm not sure if there's gonna be like a tutorial somewhere or like how to do it.
It's kind of why I started asking questions.
Yeah.
Simplex method online free. There we go. Online calculator simplex method. Oh, there we go. Yeah, well, it looks like there's yeah, you can enter the matrix. And does it tell you the stages? Oh gosh. Not
She
really.
said, "Come up in class and grab it. If not, there's a download for it."
Okay, so let me
Yeah.
okay, so here's the deal. If you come to my class, I have it on my calculator and I can bring my cable and I give it to you. If you come to her class, if you're ever like up here in campus, the learning lab has it.
Okay.
Right down the hall here. If you go down and ask them for the Simplex program, they can give it to you. You will want it. You don't want to do Simplex by hand. I mean, you do not want to do Simplex by hand. Okay, I'll just tell you that.
I've never been on campus before, so this is going to be a new trick trying to come find y'all.
Yeah, so, well, you'll figure it out. I know you will. You're smart. You're college students, right? So there are Simplex calculators online. There's different ones. And if she has one in particular she wants to use, and I would ask her, what's the website? Because when I searched it, several came up. Several look easy to use, several don't. Simplex method calculator. Let's see if something comes up. What worries me is do they want all the stages? Like the Blend program does what Blend wants it to do. It gives you the solution. It doesn't tell you the steps though. I would definitely ask her, if she has a particular website, like does she want you, there's steps to this thing. Are you guys learning Simplex Dublin right now or?
No, it's in unit 3.
Not
so
yet. I
it's
think
like-
it's in unit 3.
Yeah.
What it is you have to pick a row and column to pivot over, and so this program, you show it the row and column and it shows you the pivot, and you keep going until you don't get any negatives on the bottom, but you don't know what that means yet. But I mean, yeah, I'd want that program for sure. I mean, you can do it online. It's just I would ask her for a website just because there's some online that give you the answer, and there's some online that give you the steps. So does she want you to give you the steps for the pivot, or does she want you to just give her the answer? Does that make sense?
I don't think we've gotten to it yet, but I think she did say it was gonna be on like quizzes or an exam, something like that.
Yeah,
So
you
we
want
definitely needed to get it
that program.
for sure. I'll have to come up.
Yeah, and like I said, if we're not around, the Learning Lab has the program. I've lost it before, and that's where I got mine. I just go to the Learning Lab and say, give me the simplex program.
Well, thank you so much.
Sure. All right.
Thanks, Teach.
All right. See ya. Have a good day.
Do you think you got the cable or I go?
You can go right. If I had a cable, I'd give it to you. I don't have a cable right now, but go, the one, the testing center is right here. Just go ask them, tell them you want the simplex program. Okay. I'll give it to you.